So in this video, we're going to look at choosing the proper indicator for your titration. An acid-base indicator marks the endpoint of a titration by changing color. So the endpoint is defined as when the indicator changes color. The equivalence point doesn't automatically equal the endpoint. The equivalence point is when the reaction is just done. Ideally, we would like the endpoint and the equivalence point to be the same. We want the indicator to change color when the reaction is done. But you have to put some thought into choosing an indicator that has an endpoint at or very near to the equivalence point. You have to think about certain things in order to get it to change color at or near the equivalence point. So we choose an indicator where the endpoint pH range lies along that steep part of the titration curve. So for strong acids and strong bases, remember it's got that really tall high area where it kind of goes like this and it goes up for a while. So anywhere between 3 and 10 that you get an indicator is going to change color, because this all happens in about one drop. A weak acid and a strong base, right, kind of goes up a little bit less, and because it's a strong base, the pH at the equivalence point is greater than 7. So usually if you can get a indicator with a pKa between 7 and 11, it will change at the right place, right? And then your strong acid, weak base, your pH is going to be the equivalence point at less than 7, so you want an indicator with a pKa between 3 and 7. So let's see what that looks like So we want to pick an indicator where the endpoint pH range lies along the steep part of the titration curve. You want to choose an indicator where the endpoint pH lies along that steep part of the titration curve. Okay? So for instance, with the strong acid, strong base, there's this long rise. We just need the indicator to change color somewhere along that long rise, which goes from about 3 to 10 on the pH scale. So almost any indicator will work. The weak acid, strong base has a smaller rise, and the equivalence point is greater than 7. So you usually want something in the range of 7 to 11. So you're looking for an indicator whose pKa is somewhere between 7 and 11. Strong acid, weak base, okay, that's the one that comes down. And again, a smaller area, less than 7. So you want an indicator whose pKa is less than 7. Let's see what that looks like on a graph. So here's a couple of titrations on the same graph. The one in red, okay, this one here, this shows a weak acid being titrated with a strong base. So its equivalence point is around here, so you want something whose pKa is around there, so phenolphthalein is a really good choice. Okay? The strong acid, right, this strong acid, strong base, remember it's got this big, long area. So almost any indicator is okay. Methyl red falls right in here, no problem. Phenolphthalein, right, the pH, it's going to be right there. So, but anything that falls along this line is going to work. So phenolphthalein works, methyl red works, almost any indicator works for a strong acid, strong base titration. This big jump here occurs in one drop, so it doesn't matter what your indicator is. So here's a graph showing two things. It's going to show you a weak acid being titrated by a strong base, and it's going to show you a strong acid being titrated by a strong base. Okay? Note that for the strong acid, strong base, there's this long rise, and the pH at the equivalence point is right about 7. But notice that phenolphthalein and methyl red both fall along this long rise, so either one of them will change color. Remember, this big huge rise here happens in a single drop. For the weak acid, we've got a smaller area, okay, and the pH is going to be greater than 7. All right. So we want to use an indicator who has a pKa greater than 7. So phenolphthalein will fall in here, but methyl red is probably too low. It's going to change color before we get to the equivalence point, so it's not a good choice. If we look at the titration of a weak base, okay, with a strong acid, remember the pH is going to be less than 7 at the equivalence point, so we want to pick something like methyl red, who's going to change color along this rise here. Phenolphthalein would turn up here, but it's going to change color before we hit the equivalence point, so it's not a good choice. So you just have to make sure that you pick an indicator whose pKa is pretty close to the pH at the equivalence point. Okay, so the pKa needs to be somewhere around the pH at the equivalence point. Okay, so normally you'll be given a very short list of indicators, and you'll just have to say, oh, the pH at the equivalence point is greater than 7, so you find something with a pKa greater than 7. It's actually really easy to do.